Hello. Today we're going to explain simple harmonic motion. First, let's start with the theory and then we will go to the experiment. So briefly, the motion described as simple harmonic motion is when you have an object doing some cycles and these cycles are repetitive. We call them periodic motion. So it is characterized by a period time t.
There is a big difference between small t, anytime, and big T, the constant, the characteristic for a periodic motion. Big T is the time needed by the object to repeat one cycle.
Examples on simple harmonic motion, the pendulum and the spring with a certain mass. Now imagine that you have a wire or a thread with a mass m at the end, okay? And you deviate equilibrium position, you deviate this mass m, you take it to a certain angle theta. So the mass m, if you release it, it will start to oscillate around the equilibrium position by angle theta. So it will go to the left side with the same angle theta on the left. The time taken from point A back to A is the period T. From A to B is half period. If you have a spring of stiffness K and a mass M attached at the end of this spring, okay, and we leave it, so this is the equilibrium position. And then بيجي ولد صغير and he will elongate this mass M with a certain x and he will release it. You will notice that the mass m would start to oscillate around the equilibrium position by x max. Okay? So let's say this point is A, it would go around O لتحت x max or فوق x max. Okay? And this oscillation over here is repetitive with a period t. T is 2 pi radical m over k. Now, شو يعني الكي stiffness؟ let's imagine you have the spring هذا اللي بيلعبوا فيه الأولاد الصغار عنده stiffness كتير صغيرة. اليونت تبعيتها هي نيوتن per meter. يعني for each meter how much newton do I need to elongate it by 1 meter. هلا إذا كان عندكم spring تبع السيارة بيكون metallic for example وأضخم في عنده characteristics of the material itself is different, so K would increase. نقدر نحطه على دولاب السيارة تيحمل السيارة كلها سوا. So this is stiffness K, okay? Now let's put the mass M and we will change this mass M and we will see the effect of M on T. If we increase M, okay, T would increase, معناتها عم بياخد وقت أكتر.
The angular frequency omega, the frequency F, and the period T. I call them the package because they are all related in one formula, and if you know one of them, you can calculate the two other quantities.
In simple harmonic motion, we have an angular frequency omega, which is in هلا نشوف شو اليونت تبعها. كلنا بنعرف إنه البيريود T is in seconds. The 2 pi is an angle in radians, so the angular frequency would be radians per second. Okay, the frequency F كنا بنعرف إنه it is in hertz, F equals 1 over T. أنا هيدي I call it the most important formula in physics لأنه في كتير أشياء repetitive not only in mechanics, in electricity, in optics, so هيدي الفورمولا حتشوفوها بكل شيء physics تقريبا، كل شيء repetitive. So شو معناتها angular frequency؟ مثل الفريكونسي العادية، يعني number of oscillations per second. من وين اجت فكرة الأوميجا؟ شبهوا الفريكونسي لكل موشن، for example إذا عندي pendulum راح رجع على A، هيدا شبهوها ل 2 باي، كأنه one cycle. So كل cycle from A to A for a pendulum أو على oscillator from A to A again، هيدا شبهوها ل 2 باي. So كل period هي one cycle، هي one circle. So الانجلر سبيد او الانجلر فريكونسي هي 2 باي اوفر تي. من هون اجت فكره ال 2 باي. دائما بس تشوفوا باي يعني شيء ريبيتيتيف او سيركلر او whatever. هلا فهمنا المين ايديا اوف ذيس فورمولا. اكشلي بالاكسبيرمنت انتم بتشوفوا التي، حتى الانسان من هون 3 شغلات اذا بدنا عم بيراقب اكسبيرمنت بيقدر يقيس الوقت بيناتهم. بس actually we do related to omega لانه in calculation when بتحطوا the differential equation with solution you will get omega. So it's a way to find t if you have omega and vice versa. So نحن حنبرم على الأوميجا in this part. الأوميجا اللي هي related to the period t. Okay? But actually in the formula we can find omega. So let's find it. First of all we will go to the shop and we will buy a spring. The spring of stiffness K and length L0. So لهون من هون لهون is L0. The length of the spring. And then we put a certain mass M and we release it, okay? حيكون عنده a certain delta L from the length L0 to the new length. الفرق بيناتهم is delta L. ولأنه it's at equilibrium ما حدا عم يدق فيه, we know that the weight is equals to T اللي هي K delta L. So we already know that the weight which is mg يعني في حد somewhere إنه mg is equals to K delta L at equilibrium. Now someone came and disturbed this mass M. He elongated the mass M, or the spring actually, okay, with a certain x max. So زعج equilibrium with a certain distance x max. And he released it. So the spring started to oscillate between plus xm and minus xm. So هيدا الفيديو at time t, it's a variable, عم بيصير هيدا الoscillation. X max, okay, at this point over here, نحن بنعرف إنه في عندي كمان two forces. في نرسمهم هون أو في ارسمهم على الفيديو. So عندي الويت اللي ما تغير زيت الويت m times g, okay, وعندي التنشن بس it's a new tension T prime, okay, it is equals to K times the new بدنا نقارنها بال L0. So here from here to here هيدي new delta L حنسميها delta L prime. It is equal to الدلتا L القديمة plus الدلتا L بتوصلني على الزيرو. الزيرو هو على equilibrium, okay, plus a certain x اللي هي distance from the block to the zero. So من هون لهون في عندي delta L plus x. بس x is an absolute value. If x is negative بتحطوا minus x. مشان يطلع الانسر final positive. If x positive بتتركوها مثل ما هي. هلا إذا بتعملوا sum of forces equals MA, yes, وقت بكون في oscillation ما في equilibrium بيكون MA. And you project on the y-axis. كل شيء going up بنحط له plus, كل شيء going down بنحط له negative. T prime هي K delta L prime. It is going up, so plus T prime minus the weight equals MA. T prime هي K delta L plus absolute value of x minus mg equals ma. Okay, from the equilibrium كل ما نشوف k delta L القديمة equals mg بروحوا ورا بدلل لي k times x absolute value equals ma. In this part x اخدينا بالنيجاتيف so minus kx equals ma. Acceleration كلكم بتعرفوا ان هي second derivative of the position. ناخدها كلياتها فالدميلة صار شكلها هيك mx second plus kx equals 0. In math اسمها differential equation بس يكون عندي variable والderivative تبعها in the same equation اسمها differential equation. Okay. دايما بناخد أكبر derivative وما بنحط شيء قدامها so we divide everything by m بدلل لي هيك 0 over m بحددها 0. Actually بس تشوفوا هاي differential equation اللي هي second derivative مع ال x equals 0. Okay, it's very known to be in mathematics like this where omega هي radical k over m. Okay, كيف ازاينا من هون لهون كل differential equation بالماث عندها solution. سوري من هون لهون هاي differential equation. يس هاي differential equation. The solution x equals a cosine omega t plus phi. This is the solution. Okay, where omega is radical k over m in physics وإن math هي هاي omega squared اللي هي قدام x. ليه عم نحكي هيك؟ لأنه in math عندي omega وإذا رحت على الاكسبيرمنت رح شوف التي. What is the relation between omega and t؟ أو أشهر فورمولا in physics omega هي 2 pi over t 2 pi f.
To find the period t of a pendulum, you can work either the second law of Newton, sum of forces equals ma tangential, or sum of moments equals I theta second, or using the conservation of mechanical energy. Here I will be using the second law of Newton, projecting the forces on the tangential direction. And I will find first the differential equation, then I will deduce the solution, and the variable will be theta, the angular position theta. We have two forces, the tension T along the radius and the weight vertically down. When the mass is rotating, T will always be on a centripetal. And if you want to project on the tangential direction, which is tangent to the circle of rotation, only the component weight tangential is taken into account. When you project on the tangential direction, the weight tangential is equals to mg sine theta, and you replace sine theta for small angles by theta itself. And A tangential on the other side of the equation is equals to R theta second by definition. You cancel out the mass, so the equation is independent of the mass, and you have your differential equation in angular variables. So the final differential equation you find is theta second plus g over L theta equals 0. This differential equation is known in math to have a solution under the form theta equals theta max cosine omega t plus phi. And if you compare the physics and the math differential equations, you can find your omega, which is radical g over L. And if you want to find t, the period, it is 2 pi radical L over g, because it is 2 pi over omega.
So we have a wire of length 50 centimeters and we have 50 grams over here, and we will change 3 parameters to see their effect on the period. The first one, we will change the mass, then we will change the length of the wire, and finally in the final experiment we will change the angle theta at which the pendulum is starting. So this is the vertical, okay? With 50 grams, I'm taking a small angle, and we will measure the time for 10 periods as well. So I will start now, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 13.88. Okay. You repeat it with 100 grams. We will see if it affects the pendulum. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 13 also? Yes, 13.78 as expected, because you remember in the formula, the mass should not affect the period of time. You can repeat it with a very light mass, okay? The final one, 10 grams, 5 grams. 1, 2, 3. 2 3 4 5 6 7 8 9 10. اوكي كمان 13.25. This is the vertical at 90 degrees. If you take 10 degrees, for example, and you release it, we will set the time at 0. Let's start 1 2 3. Okay, عم يصير في friction بين الواير والprotractor. Okay, and you count 10 oscillations. You mark the time, and again you take for another angle. For example, for 20 degrees. Okay, 1 2 3. 1 2 3 4 5. Stop. Time is 7:50. 7:50 total time. 7:50 for 5 oscillations. Okay, when the angle was 20 degrees. Let's repeat it with 30 degrees. Okay, this is the vertical. Let's take it to the 60 and stop. 1 2 3 4 5. Little light. 7:13. 5 oscillations. Okay. Okay. And then you can repeat for the same angle many times to be more precise, and you calculate the average. And we will. Okay, we will change the length. We'll start with 50, and then each time we will increase it by 5 centimeters, and we will see the effect on the period. 1 2. So هلا بلشين على 50 centimeters. 1 2 3. 1 2 3 4 5. ستوب. أنا رأيي نعمل 5 طبعا نطول كتير. إذا أخذت وقت على 5.
7.
So for the first length أخذت 7 seconds قديش؟
12.
12. اوكي بس انتبهوا هودي 5 oscillations. اوكي طبعا نطول. For the first length اللي هي 50 centimeters. نرجع نطولها 5 بتصير 55. اوكي هيدي 55. Again 1 2 3. 1 2 3 4 5. stop. بدي اخذ
7.34.
اوكي. اوكي هيدي كمان source of error. So المفروض يكون parallel to the table. 1 2 3. 1 2 3 4 and 5. So لل 100 centimeter ده طلع
1040.
1040. So yes. Okay, so obviously وقت عم نكبر الأقل ال period would increase. Finally we will change the many springs. We have smaller one, bigger one, and even a bigger. Let's take one of them. Okay, هلا هيدي هي ال L0. When I put it and then I add a mass, as you can see we have 50 grams. وما تنسوا البلو support هو 5 grams as well. So in total عندي 55. Okay. Okay, بنطر الاكوليبريم. هلا it says oscillating شوي بس. Okay, هيدا الاكوليبريم. So هيدي هي الدلتا ال لأنه from L0 to the new L, delta L is over here, and then I will perturb the equilibrium. I will take it to X max, and I will start to measure the time for 10 period. Okay? 1, 2, 3. 3, 4, 5, 6, 7, 8, 9, 10. Stop. Okay? 10 period, 6 seconds, 50 milliseconds. We have 100 milligrams. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1172. Time is 1172 milliseconds. So obviously when we increase the mass, the period is increasing as well.